Welcome. Today in this video we're going to give you a short tutorial on how to obtain, process, and analyze USGS discharge data to calculate recurrence intervals for gauged streams from historical peak annual flow data. We need to start with this on the internet. And there are a number of ways to get to the data, and I'm going to give you a few examples because the USGS seems to like to change the structure and page addresses on their website about once a year. So I'm hoping that through one of these methods it'll work even if they change this after I produce the video. First of all, you can search for a tutorial on the USGS website under helpwaterdata.usgs.gov. I'll put these links in the comments. But you can search for how do I access historical streamflow data, and it'll give you a pretty good step-by-step tutorial. I'm going to go through a lot of these steps in the video. Another option is to go to the USGS surface water data page. I'll put the link for this up also. And here you can find lots of different surface water data, including current conditions, historical observations. For doing recurrence interval analysis, we would want the peak flow data from here. I'm going to show you one more option, and if you know the name of your gauging station and or the numerical station identifier that goes with that, you can search directly in Google for it. In this case, I want the USGS 07052500 James River at Galena station. We'll just search for that. The first thing that comes up is the USGS gauging site for that station. Here's a summary of all the data that's available. What we want to pick out of here is the peak stream flow. You can see we've got 96 years worth of data running from 1922 to 2017. I'm going to click on peak stream flow, and this brings us to the data page. The easiest way to get this data into Excel is to right click on tab separated file, download linked file as. The actual menu command may vary depending on operating system and browser. And then we can just give that file a name. I'll name mine James River at Galena.txt. You want to make it a txt file. And then we can open that file up in Excel. In Excel, we need to clean the data up a little bit. The first step is to take a look at the header information. The header information is all the rows that are preceded by the hashtag or pound sign. There's some important information here, so before we do away with this, let's take a look. This portion of the Excel header gives us the codes for what our fields in the data table, our columns in the data table mean. For example, peak VA is the annual peak stream flow value in CFS. So CFS is our units. So this isn't only interpreting what the fields are, but it's telling us the units. You can see that our gauge height is in feet. Site number is the USGS station number, and peak DT is the date of the peak stream flow. Alright, so we can look at these down here. We see that the peak DT, that is our date of our peak stream flow. Peak VA is our peak discharge. So now we know what those fields mean. Let's just copy. So what I did is I selected the rows by clicking on the row numbers over here on the far left side of the screen. I'm going to cut those. I'm going to come down here to the bottom and create a new worksheet. I'll just double click on that sheet tab and rename it header info. And I'm going to right click on the first row number here, number 1, and insert cut cells. I like to do this because this preserves that header information in case you need it later if you come back to the file or if you forget what some of this stuff means. Back on our data sheet then, we can right click on any one of those row numbers and delete, and that moves our data to the top. Just to make it easier for you to see these column names, I'm going to wrap text and center things up a little bit here. Our second row in the data set, 5S, 15S, 10D, these are codes USGS inserts in here. We don't need them for our purposes today. And we also don't need any of the information in these columns after peak discharge, which is labeled peak VA right now. So I'm just going to select those columns and delete. And then I'm going to select column D, and I'm going to choose delete to clear all the data out of those columns, but I'm going to actually leave them here. And then I believe we're going to need 3 more columns to process this data. So I'm going to click on column E, which is where the peak discharge is, and select 3 columns, right click on that column heading and insert, and that gives us 3 new columns, so 4 columns before peak VA. What we need here is calendar year, water year, ranking, and recurrence interval. Next, we need to set the calendar year for each of the observations in the data set. There's a simple formula we can use in Excel to do this. The formula year, or the function year, extracts the year from a date. So in this case, we would use the Excel function equals year, open a parentheses, and then whatever date is in cell C2, the formula will extract the date from that value. We'll use in a few moments a similar formula or Excel function called month, which takes the month out of a date. Go back to Excel. We can enter our formula year C2 to extract the year from the value, date value. What I did there is click in the lower right corner of a cell, and you can see that the cursor changes from a wide, sort of a fat white plus sign to a skinny black plus sign. Double click and it propagates that formula through all your data. So it's a quick way to extract all those years from the values. Next we need to talk about the USGS water year. So a water year for USGS runs from October 1st through September 30th. So for example, the 2018 water year runs from October 1st, 2017 until September 30th, 2018. A good example of this would be if our peak discharge value occurred on October 31st, 2017, that would be part of the 2018 water year. So hypothetically, we could have a peak discharge, say, in April of 2017 and another one in October of 2017, and both of those 2017 discharges, one in April, one in October, could be the peak value for their water years. So our peak 2018 value may come from October, November, or December of 2017, and our peak value for the 2017 water year could come from 2017 prior to October 1st. So we can use a formula in Excel to decide whether each discharge value is which water year it goes in. So the formula would be if, that's the function in Excel, and then the if function has 3 arguments. The first argument is the logical test. We're going to test if something is true. The second argument is what to do if that test is true. And the third argument is what to do if that test is false. So in this case, our logical test is that month function that we looked at a second ago. We're going to extract the month from the date, and if the month is less than or equal to 9, in other words, if the month is September or before that in the year, then the calendar year and the water year are equal, so we can just take the value from the calendar year, which is in column D. Else, if the month is 10, 11, or 12, October, November, or December, then the discharge value represents a water year that's different from the calendar year, so we have to add 1 to the calendar year. The example here would be that discharge we talked about that might have occurred on, say, October 31st, 2017. That would be part of the 2018 water year, so we have to take the calendar year for that observation and add 1 to it to shift it forward to the correct water year. Alright, we'll go back to Excel and we can put that function in. If month, so if the month of this value is less than or equal to 9, then we want the calendar year and the water year to be equal, else we need to add 1 to the calendar year. Once again, if we right click in this bottom right corner, we can propagate that formula all the way down, and this is a good example right here. You can see that there was a big flow on June 20th, 2015. That's part of the 2015 water year and the 2015 calendar year. We also had a peak flow on December 28th, 2015. So that flow occurred in 2015 calendar year, but it's part of the 2016 water year. So this is a good example of why we need to differentiate the water year from the calendar year. Alright, the next thing we need to do is to sort our data by discharge value. And I'm going to go ahead and change the name of this column from peak VA, which just doesn't mean much to me, to peak discharge and CFS. Okay, those are our peak discharge values. Alright, I'm going to click on our upper leftmost cell, agency CD. I'm going to hold down the Control-Shift right arrow, which will automatically take me to the end of the data, and then while I continue to hold down the Control-Shift, I'll choose the down arrow, and that was a quick way to select all the data. And then we want to sort that data. So in the data ribbon, we can choose sort, and then it recognizes, because this box is checked, that our first row of data is actually headers, values for each column. We're going to choose the peak Q CFS and then arrange those from largest to smallest. So now we've sorted our biggest discharge to the top of the list and our smallest discharge, which was in 1934, to the bottom of the list. Now we need to rank those. The biggest one is number 1, the next one is number 2, but we don't have to type all the way to the bottom. We can just select after we've got 1, 2, double click on the bottom right of that cell, and Excel is smart enough to know that, to see that pattern, that if we type 1, 2 and we double click, we must want to just count down the list. That leaves us with our highest value being 96, which is how many years of record there are in this data set. So we've ranked from 1 to 96. Now we're ready to enter the recurrence interval formula. As you may recall, the recurrence interval is equal to n plus 1, that quantity, divided by m, where n is the number of years of record, so in this case 96 years of record, so 96 plus 1 will always be 97 divided by the rank. So our biggest discharge in the list, our number 1 rank, will be 97 divided by 1, or a recurrence interval of 97. Our second biggest discharge in the list will be 97 divided by the rank of 2, so 97 divided by 2, and the result of that function will be the recurrence interval for that second largest event. In Excel, we're going to do this with a function that uses count ff plus 1 to determine n plus 1. And what the count function in Excel does is it counts the number of discharge values in the list. Now, it will ignore any non-numerical values in that column or in that array range. So by using ff, we're telling it to look for everything in the F column, but it will ignore that first row which has text in it and only count the number of numerical values. So that will give us that value of 96 plus 1, which will equal 97, and then we'll divide it by the rank, which is in cell F2. Now, the reason I do this count is for two reasons. Several of the data sets that I maintain recurrence intervals for, this way what I can do is just add the newest year's data every year once USGS updates the data set with the most recent water year peak discharge, and my formula automatically goes up to date. I add one more in, then the n goes from, in this case, 96. Next year the n will go to 97, and I don't have to change my formulas. The other reason for this is sometimes data sets are missing years. For whatever reason, data wasn't collected for a specific year. I was working with a data set recently, and I noticed that in the World War II period, they didn't collect any data. Maybe they didn't have the budget or the people to go out and do the data collection, but for whatever reason. So this counts, and even if the data set runs from 1900 to 1999, because some years are missing, the actual numbers, the actual n may be less than 100 in that case. If we were missing 10 years, it would automatically determine that there were only 90 years worth of data. All right, so we can come back to Excel and put that discharge or that recurrence interval formula in. Count ff plus 1, close the parentheses, and divide by the rank, which in this case is cell F2. Double click on that bottom right corner, and if it bothers you to have a lot of extra significant digits there, you can correct that pretty easily in Excel. And what we see is we've got 97, 48.5 as our second recurrence interval, 32.3. If we come all the way down to the bottom of the list, move some extra decimals out there, you can see that our lowest recurrence intervals are getting closer and closer to 1 year. So we've calculated all the recurrence intervals, and now it is time to graph the data. The easiest way to graph the data will be to select the two columns that we want to graph. We want to graph recurrence interval versus peak discharge. We want recurrence interval to be our x-axis and peak discharge to be our y-axis. So I'm just selecting those two columns. I'm going to go to the Insert ribbon, and it's important that you use a scatter plot here. Don't use any of the other types, not a line plot or any of the other types of plots that they have in Excel. You can see it's not going to give you the right type of chart. We want a scatter plot. Now that dumps the scatter plot here in the middle of our worksheet. I'm going to right click in the white space here and move this chart to a new sheet, and I'll just call it RI graph. And that puts our chart full screen here on a new sheet. Alright, now we need to make some changes to the default settings on the graph. The first thing we're going to do is double click on the x-axis. So just double click on one of the x-axis values. I'll double click on 20. That brings up the format axis panel here on the right. And the first thing we want to do is check logarithmic scale, because we want a semi-log plot, meaning we want our x-axis to be logarithmic and our y-axis to be linear. So we'll check that, leave it at base 10. That makes our x-axis logarithmic. We'll set our maximum to 1000, and that's because later in this exercise I'm going to show you how to forecast out data to predict higher recurrence intervals like a 500 or 1,000-year flood. I want our major units to be 10 and our minor units to be 10. And then we want to turn on tick marks. So the major type of tick marks, I prefer to make the majors crosses and the minors inside. You can see those show up down here on the screen then. And note, on a logarithmic scale, we have 10. The next tick mark over would be 20, 30, 40, and so forth. Starting from 100, it would be 100, 200, 300 would be over here, 400, 500, up to 1,000. And the same from 1 through 10. That's the way a logarithmic scale works. Alright, now we need to create a little extra room on our y-axis. I'm going to double click over here. That changes our panel to the y-axis. And I'm going to make our maximum about 140,000. Leave our major unit at around 5,000 and our minor unit at 1,000. Alright, and I think that's everything we need to change on the y-axis. Now I want to do one more thing. I'm going to right click very carefully here on the vertical line for the y-axis and add minor grid lines. That puts in the minor grid lines at every 1,000. I'm going to do the same. I'm going to right click on one of the x-axis minor grid lines and add those. And you can see it's added those vertical lines in and horizontal lines for those grids. That's going to help us read the graph values later for the assignment I'm giving for my class. So that's just a matter of convenience. Then we need to do a couple things to pretty up the graph, especially if you were in my class. I'm going to click on the graph here and go to the Design ribbon. Add chart element, axis title, primary horizontal. Add chart element, axis titles, primary vertical. Double click on the vertical axis title and we'll call that peak discharge in cubic feet per second. And then we'll right click on the horizontal axis and that should be recurrence interval in years. And then if you're submitting an assignment to me, you always need to have a good title on your graph. An example of a good title for this graph would be Recurrence Interval of Peak Annual Discharges at the James River Gaging Station at Galena, Missouri, 1922 to 2017. I'm just going to select that whole box here, come back to the home, make it bold just because I prefer it that way a little bit. Alright, we're almost there. We've almost got our graph. Next we need to right click on any one of the data points. That gives you a context menu with the choice to add a trend line. Under the trend line, we want to come over here to the trend line formatting panel and choose logarithmic. That gives us a nice trend line. We want to display the equation on the chart and the r-squared value. And you can see from the r-squared value, a perfect fit for the data would be 1.0. We've got 0.9855, so this is a good fit. And then we'll forward forecast this. Remember, we had 96 years of data. Let's say we want to find out what the 500 or the 1,000-year discharge is. Let's just, we've got 96 years, so we need a little over 900. So we can forecast forward 904 periods, which should get us out to about 1,000 years. So that forecasts that trend line out to the 1,000 years, which is the right axis on our graph, and that allows us to estimate, say we wanted to know the 100, 200-year flood. Looks like the 200-year flood would be approximately 105,000 cubic feet per second for the 200-year flood based on that forecast. If you're in my class, there's one more step or a few more steps actually, that you need to take to prepare your assignment for submission. First, let's switch to Microsoft Word, or whatever word processing program you prefer. And we need to put some basic information at the top of the document. Your first and last name. Maybe we'll put recurrence interval exercise in there so that the instructor knows what you're submitting. List of the questions. There are several questions on the exercise that you'll need to answer. You can just put number 1, type your answer there, number 2, type your answer there, and so forth for however many questions there are. Then leave a couple of spaces here. I've got, by the way, these paragraph symbols that you see at the end and soft breaks. I've got my paragraph marks turned on. You may not have those. It doesn't really matter. The point, though, is hit a couple of carriage returns and then put your cursor on one of the ones that's not the last one. We don't want it down here. We want it at one of the previous ones. All right, let's go back to Excel. And I'm just going to click somewhere out here on the perimeter of the graph. Right click and copy. Go back to Word. Paste that in. You can see it pasted in all nice and neat there. Then I'm going to create a page break, which you can do with Control Enter on Windows or Command Enter on Mac. Or you can just hit the line return, the enter button, several times till you get to a new page. And you also need to submit an example of your data table. And what I would like you to do is to select a row, come to the Formulas ribbon, and show formulas. What we need to do is switch back to the data table. You don't need to put the whole data table in, but maybe the first 10 or 15 or 20 rows, something like that. I'll just select some here. Copy. Come back to Microsoft Word. Paste. You can see the table is pasted in. And then just save the file. And give it a name, maybe your last name, and a little description of what's in the file. This would be the James River RI analysis exercise. Hit save, and it's all ready to submit. Alright, well, thank you for following along. I hope this video was helpful. And something that you can refer back to as you do the exercise to help you solve some of the little technical issues or questions you may have about getting Excel to do it exactly like we want it done.